Okay, so to quickly pick up from where we left off, we were just messing around with this little example from the camera kind of thing of being able to instance objects rapidly and then applying some fun mathematical equations to create some pretty cool effects. And what's really unique about this particular demo that you can see is that there's only one object. We're only creating one cube, and then we're rendering it with different transformation matrices. And this is what's called instanced rendering. So I wanted to quickly go through one of the examples in the repository. This is the managers and instancing C16. So let's really quickly just run it and see what that looks like. And let me run it in release. So here we do have the camera, although it doesn't seem to be functional. And you can see that we're instancing tons of objects. In this case, 176,000 objects. That's a pretty crazy amount. And the way that we're doing that, like if we were to run, just showed like before we were running the example with instancing this one, we didn't really try to figure out at what point this would crap out. So let's try that out. Let's see. Right now we were running 32 by 32 by 32. How many objects is that? We were doing 32,000. So what if we did 64? What would that be? 64 times 64 times 64, so 262,000. Let's see if we're able to do it. We can, but our frame rate's pretty bad. So, it's cool though, it's not terrible. But that's a lot of objects to be rendering. So let's go back to this example. So, as usual, I'm going to go through this project really quickly. We already know we are creating an application, we're initializing it. We already have our camera, so you'll notice there's a lot more in this class than what I wrote. There's some other functions as well. We have our MyMesh that we've gone through our primitives and the ability to create different kinds of objects. And then let's take a look at our app class. And our app class is effectively creating a camera, setting a position and a up vector, and also the sort of what you're looking at. So we talked about the look vector, we talked about the up vector already. And then we're creating this mesh manager. And the mesh manager is an object provided by the BasicX or the Simplex framework that Alberto put together. And the idea here is here's a manager that is effectively letting you create objects, but as an instance. So you can see here, most of the work is being done in update, where we have a update, we're updating the system, and then we're going through 420 times 420 objects, and we're adding cones to this render list, and we're translating them accordingly. And then it shows how many objects we have, which is going to be the n count, which we're incrementing every single time. Actually, it's not 420; it's 840 by 140 because we're jumping by 2, so it still is 420. And then we're incrementing by 1, and then all we're doing is we're hitting render on the mesh manager, and it tells us how many renders we've called, and the result of that, as you can see here, is all of these objects being rendered in real time, and we're getting about 45 frames per second. So you can kind of see it's comparable to what we were doing before. When we hit 260,000 something objects, we were starting to chug down. But if we go down here and we increment by, say, 4, which will be half of the objects, right? We'll probably get 60 frames per second pretty reasonably. So let's see what's happening in this render function. Okay, so let's go into the mesh manager in basics. And we are hitting render, so let's find render. Okay, that's going to take forever. There we go. Okay, so what's happening is we're going through all of the meshes. We are basically pushing back an option list into the solid list, which is just a vector. It's not a vector like a math vector, but a vector of transformations actually, and then we go and we start to render the solids. And what we're doing really is we are from calling the camera manager, getting the projection matrix, getting the view matrix, and then getting the position of the camera manager and rendering the object, as you can kind of see here. And let's see. Yeah. And here is where we're copying the array, the solid array, which is it gives all of the information. It's basically just a large array of data that we're going to be pasting all of our transformations into. And then we're going to go through the solids. Oh, never mind. This is not going through them. It's actually rendering the whole thing by going through the mesh list, which is going to be a mesh. So let's take a look at the render. And the render is going to go in. It has the number of instances that it needs to render. So if you need to render 20 spheres, it's going to have 20 spheres, and the matrix array is going to be 20 times 16 in size. And obviously it's going to choose if it's going to be solid or wire, but in both cases the matrix array, it's very similar. And then let's take a look at this render solid. And here you can kind of see a lot of the kind of core rendering code. There's a lot of stuff in here that you haven't seen yet, like textures and stuff like that. But let's take a look at where we get the model matrix. Because at this point, we're already rendering, we know what object we're rendering. We're rendering a type of, a type of mesh. And the mesh list here, as you can see, is, let's go here. Like the mesh list is a bunch of meshes. And so this object already knows what kind of object it is. Oop, where do we go? And let's go to render solid. And then, so let's try to see here where we're in the, where we're setting our model matrix. So our model to world starts off as a identity matrix, and then we get the VP, or the view projection, which is just the multiplication of the projection times the view, and we're going to set that to the shader. So this shader is using a view projection matrix separate from the model matrix, and the model matrix is being set independently of that. And then you can kind of see here, actually, the model to world, the uniform, is being set as the a matrix 4 value pointer of the model? Okay. Yeah, it looks like so I'm not sure why this code is up here. M4 model to world is being set initialized to an identity, but down here is actually where the code is happening. M2 world is being set to a particular section in this matrix array. So you can see this that is being passed in is basically a long array of all of the model transformations of the individual primitives, and this is where we're setting that and passing it in. So what's this doing is it's passing in the section number. So you're starting at a particular point, and you're reading a certain number of them, and then you're going to draw instanced the reminders. And so this draw arrays instanced allows you to draw many different, basically the number of remainders that you want to render. I guess it's already happening. It's already doing it up here. But this is in case you're doing it's doing it in batches of 250, and so the remainders is being done here. So to kind of recap, and I'm not explaining this particularly well, I'll also post Alberto's explanation of this. I think this is his code, and I'm not as familiar with it. But what's happening is you're able to pass into OpenGL instances in this way, in the number of instances. In this case, we're batching it by 250. And then we're passing to it 250 of the transformations. And then we're using the shader. And then we're drawing an instanced array 250 times. There is a limit to batching, and that's the reason why you can't do more than a certain number before your API kind of craps out on you. So hopefully this is kind of a decent explanation of the instanced rendering approach with OpenGL. You're using the GL draw arrays instanced. But if you have any left over, if you're doing it in batches of 250, you might have 255 objects, and so you might have to do a few remainders, which is what this is doing. Any number underneath, it's going to be caught by that second bit. So if there's 0, it's just going to kind of pass right through there. And the VBO is being bound right here, the VAO I mean. And so this mesh, it already has been initialized to a sphere, to a cube, to whatever, and there's only one of them, as you know, and that's being, again, done by the manager. So the render is actually pretty straightforward in that we're basically going through the meshes in the list that you have, this can be a number of them. We're going to go through this mesh by mesh, which is going to be probably a bunch of different object types. So the meshes are going to be probably a cylinder or a cube or a sphere or what have you. And that's how we're going to know which ones to render and what their transformations are, which we're going to copy into the GPU. However, how do they get in there in the first place? So let's take a quick look here. You can see every update we're adding a cone to the render list. And that seems kind of unintuitive. Like, why would we add it every single time, every single frame? Why would we add it? Why not just render it over and over again like we were doing previously? Let's take a quick look at this code. Adding a cone to the render list. What we're doing is we're just calling add mesh to the render list with a number. What's that number about? So we go to this function, and you can see all we're doing is this render list with the index being some just value. We're pushing back this transformation. So like we saw before, we had this big chunk of transformation data that we passed to the GPU in one big batch, right? 250 transformation matrices at a time, and we're pushing it to a particular index. And that's because the index represents the type of the mesh, be it a cone, be it a square, be it a whatever. And that is being done actually early on, where let's see, this is being added to a render list array. So let's take a look at render list and where it's defined. You can see the render list is defined as a vector of vectors. And let's go to the render list where it's defined, where, at this point, let's see, at this point, we already assume that there's an index there. So where do we initialize that thing? So let's take a look here, right? In the initialization of the mesh manager, we are initializing a cube, a cone, a cylinder, a tube, a sphere, and a torus. And you can see that these represent 0, 1, 2, 3, 4, 5. So let's just kind of play with these numbers just to kind of see how this works. If I run this, we have a bunch of cones. But say I move the cone and the cube and I replace them. We would expect the two to be flipped, so now we'll have a bunch of cubes. And so you can see how this looks. It does a lookup, and this is just kind of a clever way to organize your objects and have some kind of organization. Because when we look at the actual code here, let's go and look at generate cube. The generate cube, it creates a new mesh, and then it generates that mesh. So here we're creating, much like we did before, we made a mesh like a cone or whatever, just like we did in this part of in our previous project here, right? We generated a cube. So what we're doing inside the mesh manager, it's creating one of each one of these objects, right? And then when we go to add mesh, you can see it checks if it's empty, it does some error, it figures out the mesh index, right? Which is just like the way that we want to find the next index to go to. Oops. And then we push that mesh back into our mesh list, which is respective to, again, lines up with this array indexing system that we have. And then we have a render list for this mesh, which we then pass to our render list, which is what we're using to render, right? Like our render list is first we're doing mesh list render, that's the particular object, and we're rendering with our render list. That's it. That's the system. It's a bit interwoven, but ultimately think about it like this. The mesh manager manages a set of primitives, a set of meshes, and then to that you're saving a bunch of transformations in like almost like a queue. And then you render through that queue, you just render it a bunch of times in the same way that we did it here. Right here we're going through and we're creating a transformation matrix that we're then passing to this render call of the particular mesh. And the mesh manager, what it's doing is it's just generalizing that for these particular mesh types. So you can imagine if you didn't want a particular type, you can get rid of the torus, you can get rid of the sphere if you're only going to be using cubes and cylinders and what have you. There are a lot of different ways to do this. Batching is a very, very good technique to use when you want to do huge amounts of rendering, like hundreds of thousands of objects like we were doing just a second ago. And the reason that that's the case is you're limiting the amount of bandwidth on the bus, or not limiting it, but every draw call takes up a lot of time. And so if I could, I'd rather do many draw calls at once. So batching allows you to do that. This particular call here, where are you? This call right here, the GL draw arrays instanced here and here. What it is doing is it's basically allowing you to call the draw call with a number of things. So like for example here, the GL draw arrays instance allows you to call the shader many times with one chunk of data that it's then indexing in a similar way that we were doing with the index buffers, but for transformation matrices, for example. And that's a really kind of powerful thing. It's not necessarily passing each transformation and indexing it. It just allows you to provide a big chunk, and on the shader side, you're able to run that multiple times with different values in a different kind of scenario, with a knowledge of that index count, if that makes any sense. So that's the way you would do it. In fact, if we really want to take a look at the shader, that might kind of provide a little bit more information here. Oops. So let's take a look at the shaders that we're using here. So let's take a look at Simplex Vertex shader. And you can kind of see M4 to world GL instance ID. And the GL instance ID, let's take a, oops. Let's take a quick look at this. GL instance ID is a built-in variable in the GLSL language that contains the index of the current primitive in the instance draw command. So say I'm uploading 250 transformation matrices, I can then index through those using M4 to world. And the reason that I have to limit that number or set it, as you can see here, this is hard-coded. I can't have a dynamic value every single time. So hopefully that is a reasonable explanation of the My Mesh Manager capability in Simplex. But I want to really make it clear, instance drawing and instance geometry doesn't have to be that complicated. You can benefit from it just by having one object, and really at the end of the day, when you have a vertex array object with a buffer inside of it, you're already doing instanced rendering. But this allows you to be a lot more performant, and you can render a lot of stuff, largely because of the fact that you're not, you can call these render calls with one draw call. And that's what instancing is really for, is to really improve the speed at which you're hitting it. And you don't have to create new objects. You don't have to create a new cube every single time you draw a cube. You only have to create one cube and then use that and then apply to it different transformations to make it look different, like bigger, smaller in different places and so on. So that's about it. That hopefully covers the instanced rendering and how the Mesh Manager works. Cool.